We lost, I think, 16 of you here. Give another 1 minute. So I think altogether, I think 25 of you, I think. So give another 1 or 2 minutes. So I think, okay, let's restart our lesson. So I think 17 or 18 of you, yeah. Okay, let them slowly come in. Okay, our plan today is to do this topic 7. We have about, so we'll be going through, go through the A2, go through the A2. We have about 16 topics overall in A2. Okay, so we're done with 6. So this is another 10 to go. Okay. So it's going to be a very fast movement. So I think we're going to move quite fast. Okay. So any questions? So I hope you have the slides in the time in the Moodle. Okay. Okay. So this topic is we learned partially in AS already. AS we learned the first two, 7.1 and 7.2. Okay, today we're going to continue with the other 3. Okay, electric field is 50% in AS and 50% in A2. Okay, AS you learn about electric field and uniform electric fields. You only learn about uniform electric fields. Okay, you learn about uniform electric fields. Okay, today we're going to learn about a non-uniform electric field more in depth. Okay, non-uniform electric field. So the electric field topic is going to be about the same flow as gravitational field. Okay, what I mean by same flow means gravitational force. You learn about gravitational force. After you learn about gravitational force, you learn about gravitational field strength. After gravitational field strength, what do you learn? You learn about gravitational potential, and gravitational potential and gravitational potential energy. The same thing going to happen here in electric field. It's going to be electric field strength, electric force, and we're going to talk about electric potential. Okay, so all of you can see the slide, right? Everyone very silent today, yeah? Okay.
Yeah.
Can, okay, good. So this is what the outcome we have to do. Okay, let's continue. Okay, first, the electric field is about Coulombs law. Exactly same as Newton's law of gravitation. Okay, anyone, what is Newton's law of gravitation say? I have to recall back the gravitation law every time. Okay, because it's about the same flow. What is the Newton's law of gravitation say? The force is directly proportional to the product of masses and inversely proportional to the square of the distance. So F equals to gmm over r squared. You have to recall back. Same thing what Coulomb's law said about charge. So Coulomb's law says exactly same as what Newton said. We talk about the charge. He talk about the charge. Electrostatic force. He talk about electrostatic force. The electrostatic force interaction between the two charge particle proportional to the product of charge and inversely proportional to the square of the distance. Okay, the mass in gravity is replaced with the charge here. Okay, so a charge separated for a distance of r. So according to Coulomb, he said the force between these 2 point charges is directly proportional to the product of charge. Okay, more greater the charge, more greater the force. Okay, and you see it is inversely proportional to the square of the distance. So therefore forms the electrostatic force between charges, point charges is F equals to K Q1 Q2 R squared. Okay, identical to what? Identical to like force for gravity last time. Okay, I think for gravity force is what? F equals to Gmm over R squared. The same part. Instead of charge, it was mass. It was mass. The M has been replaced with the Q, and constant is not anymore G. It's a new constant K. We call it K. It has a value, a different value than G, of course. Okay, the force is inversely proportional to the R squared. When R get greater, the force get weaker. Okay, double the distance, the force become quarter. Okay, so the force become quarter, correct, right? And the R become 2R, okay, the R become 2R, K, Q1, Q2, when R become 2R, 2R squared, the force become quarter, what? Quarter K, Q1, Q2 over R squared. So the force become quarter F, quarter F, as stated here. When distance double, force become quarter. When double the charge, the force increases by factor 4. Yeah. Instead of Q1 unit, now you put 2 unit for the both, the force increase by 4 times, 4F. Okay, 4F. Okay. Okay, so directly proportional to Q1, Q2. Direction of force, of course, like charges repel, unlike charges attract. Okay. This we skip, this we do one. Okay, Coulombs law, F equals to K Q1 Q2 R squared. The K actually represent with this formula, 1 over 4 pi epsilon naught. Okay, and so K is 1 over 4 pi epsilon naught. The epsilon naught is actually called as permittivity of free space. It's another constant actually. If you have two charge and the region between them is a vacuum, if it's a vacuum, okay, if it's a vacuum, sorry, where is it? So if it's a vacuum, then the constant is 4 pi epsilon naught. Okay, if the vacuum is if the two charges are filled with air, then the constant going to change. The constant for electric field strength, electric field force, is not always constant. It depends to the what type of what do you call material fill the space. Okay, if it's vacuum, then it's going to be 4 pi epsilon naught. Your syllabus just vacuum, so we just take 4 pi epsilon naught. The epsilon naught is called for permittivity of free space. Okay, so the equation should written like this: 1 over 4 pi epsilon naught Q1 Q2 over R squared. In exam, of course, this looks very convenient for us to write as K, but in mark scheme looks like they prefer you to write like this format: 1 over 4 pi epsilon naught, okay, Q1 Q2 R squared. Okay, so this is the force, the Coulombs law. Okay, the permittivity is the ability of the material to transmit permit in electric field. That's called permittivity of free space. Okay, so this 1 over 4 pi epsilon naught is 9 times 10 to the power of 9. Okay, but in your front page of your question exam paper, the front page, the constant K not provided. The one provided is the epsilon naught. Only epsilon naught is provided. 8.85 times 10 to the power of negative 12. Okay, so in exam you have to put 8.85 times 10 to the power of negative 12. This is going to eventually end up getting 9 times 10 to the power of 9. Okay, so in exam, if they're asking for the force, two charge force separated, the formula I want you to write is the 1 over 4 pi epsilon naught Q1 Q2 over R squared. Okay, this is the formula you're supposed to write. Epsilon naught is the one given in the front page. Okay, one example about Coulombs law. Okay, so you see here, by assuming that the hydrogen atom consists of an electron of charge E orbiting a proton of charge E plus. Okay, calculate the force between the electron and proton. What is the force between electron and proton? If the diameter of the hydrogen is 3 times 10 power negative 15. Okay, so they're asking what is the force between the 2 point. Okay, so you have hydrogen atom consists of electrons, so you have calculate with the electron and proton. So you have proton in the nucleus and you have electrons going around. So what is the force between them? Okay, so according to Coulombs law, of course, force is what? F equals to K Q1 Q2 R squared. So what is the Q1 Q2 of the electron and proton? You have to include that. So the solution, of course, the bottom number 4 pi epsilon naught E. What is why E? Because proton charge is 1e, the electron charge is 1e. They're separated by how much of distance? The r. The r is 3 times 10 power of negative 15. The distance between. The distance is, we take it same as gravity. Let's say the sphere of the charge is quite big. Then we take from the center to the center as the r. That's your r. If it's too small, then not possible. But if the sphere of the charge is quite big, then we take center to center as r. Okay. So when you find the force, the charge, right? Of course, proton is positive, electron is negative. Remember, no need to put the sign of charge. No need to put the sign of charge. Just put the magnitude only. So in this case, the force is found to be under 2 Newton. Just a direct substitution. Okay. So yeah. So this is how you find the force. K Q1 Q2 over R squared. K is 1 over 4 pi epsilon naught. Okay. Okay. So another one question. 1 minute for you. Can you use that formula? Get me the answer for this. Predict. Of course, the answer is at the bottom. Imagine what do you think you're going to write. The charge on the uranium nucleus. The charge on the alpha particle is given. What is the electrostatic force between the uranium nucleus and the alpha particle? Separated by 1 times 10 power negative 13. So use your, one is uranium, another one is alpha particle. Alpha particle separated by a distance of 1 times 10 power negative 13. Okay, so find the force. So the formula is K Q1 over Q2 over R squared. But in exam, preferably to write 1 over 4 pi epsilon naught Q1 Q2 over R squared. The charge, sign of charge, not to include. So of course, so here the charge, you can't put Q here. You can't put Q. You have to put Q1 Q2. Sorry, you have to put Q1 Q2. Q1 is 1.5 times 10 power negative 17, and Q2 is 3.2 times 10 power negative 19. You get the answer. Force. Okay. In a real examination, normally, like alpha particle, they won't tell you the charge. They won't tell you the charge. You have to find the charge. How do you find the charge of alpha particle? So alpha particle, you should know it made of what? It made of helium 42. And which value determines the charge? The proton number or the nucleon number? The proton number determines the charge what? Okay. So the charge of helium, the charge of alpha should be what? Is 2 times E. E is what? Of course, E is the elementary charge, 1.66 times 10 power of, 1.6 times 10 power of negative 19 elementary charge. So you get the charge. Because the charge is written as here 3.2 times 10 power negative 19. Okay. So next time, normally the charge not given. You have to find the charge. Take the proton number times with E. Okay. Same thing for any other substance. Let's say they give uranium 23585. Find the charge of this nucleus. So what is the charge of this uranium? You must do 85 times
E.
E. So you get the charge. Okay. Any questions so far? Okay. Okay. So as we move on. Okay. So now it's your turn. This is the difficult one. Okay. Try to think what is the answer should be for this by using F equals to 1 over 4 pi epsilon naught Q1 Q2 over R square. Force between charged particle is this is what Coulombs said. Product of charges inversely proportional to the square of the distance. Okay, look at this question. A is positive, B is negative, P found to be positive. P found to be positive. Okay. So calculate the force on the charge at P due to A and B. Okay. What is the force on P? What is force on P caused by these two charge? Okay. So our focus is the P. What are the force acting on P caused by the A and B? Okay. So A positive, P also positive. So A going to exert a force F1 or F2? Because like charges, okay, positive, positive. So B going to be pushed by A, right? So the force caused by A on P will be F1 or F2? Should be F1, right? Right? So F1 is force caused by who? By A on P, on P, correct? Okay. Then F2. F2 definitely force caused by who? By B, right? B is negative, P is positive. So B going to pull the P to the left. So F2 is force caused by B. F2 is B, B on P. You calculate the force on the largest charges on P due to A and B. So what is the net force? What is the net force? Net force acting on P. So of course, the both force we have to add or subtract. So we want net force what? So we subtract because the force is in opposite direction. So use your common sense, you have to subtract. So tell me, just looking at the values, tell me without calculating. Tell me, is it F2 going to be greater or F1 going to be greater?
F2.
F2 is going to be greater. Why?
Closer.
Closer, yes. Closer and greater charge. So therefore, the net force, we use our common sense, should be F2 minus F1. We say F2 minus F1. After we get the answer, we say the net force is to the left or right. We say the net force is to the left. It's to the left. The net force is to the left. So F2, we use this formula. Okay, we use this formula. So to get F2, Q1, Q2, we put of course the charges, the both charges. If the force is caused by F2, F2 is force caused by the B. B, your charge Q1 must be charge of B, charge Q2 must be charge of P. Do you include the sign? Don't include the sign. Don't include the sign. Just get the magnitude only. And the R is their separation for centimeter. Put it in meter, so you get the force law. So that's the idea of A. Okay. So A. Okay. So if you substitute, I show you the working. I think you should be able to get this answer. You should be able to get this answer. So negative shows is towards B. Here in the working, the sign of charge is included. The sign of charge is included. -5 is included. Okay. My advice: you don't need to include the sign of charge. Use your common sense. Find which force is greater than which force. Minus them. You just tell the direction. Okay. The sign of charge no need to include. Okay. So I believe any problem with this working shown here. So understand, just direct substitution. Okay. So K Q1 Q2 over R squared. Here the working 9 times 10 to the power of 9 has been replaced straight away as K. But as I told you in exam, write 1 over 4 pi epsilon naught. Okay. Then directly you can substitute as 9 times 10 to the power of 9 if you want. Okay. Okay. So that's the answer for the force. Okay. The difficult part, I go back to the question, is the B. Okay. 1 minute for you. Read the question. Okay, part B is a little tricky. Okay, without calculating. What the question one actually? At what point on the line of AB, at what point on the line of AB along this line, could there be no force on the charge P? No force on the charge B. No force means no net force. The net force is 0. Okay. Find there is no net force on charge B due to A and B if P were placed there. Okay, tell me, where do you place the P along the AB, along this line, horizontal line? Where do you place the P so that the net force of P, the net force experienced by the P is 0? Okay, let me give you some choice. Is it you place this first region somewhere here, 1, or you place the P in between here, 2, or you place the P here, 3. Think carefully. Where do you place the P? The P can tend to have can have 0 net force. At 1, at 2, or at 3. 0 net force means what? 0 net force means the force caused by B and force caused by A on P must be same magnitude, right? Must be same magnitude, must be acting in opposite direction. So 1, 2, 3. If you place the P here, is it possible for the net force become 0? Or you place the P in between here, the net force can be 0. Or you place the P somewhere here or move around here, somewhere here, maybe P. Net force can have chance to become 0. Where? 1, 2, 3.
3.
Oh, good. Yeah, it's going to be 3. So see, 3 is good. Yeah, 3. Why 3? Why 3? It's a very long-winded. But let's see why 1 or 2 and can't first. Why 1 cannot? Why 1 cannot? Because F2 always going to be greater than F1 wherever you place the P on the 1, right? Because why F2 going to be always greater than F1? Because F2 shorter distance, then the charge of B is greater than the A. So the product of charge is big, the R is big, the product of charge is big, the R is small. So the F2 going to lead to the greatest value. So no way F1 going to balance the F2 at the first region. Second region, what is the problem? Why it can't achieve the net force 0? Because B is exert force to the right because it's negative and P is positive. And A going to push the P to the right too. The both force going to act in the same direction. So no way net force going to be 0. I think the third region is the best because A going to exert a force to the left, right? Okay, the force of A acting to the left because positive. But force caused by B is going to be to the right, force B. But now it's very good because charge is smaller but distance is shorter. So for the case of A, the force A, the charge is found to be smaller, but the distance also shorter compared to the force of B. Force of B, charge is greater, and the R also greater, further away. So there is a chance for the net force becomes 0 here. Okay, class, 1 minute for you. Can you find what is the distance to find the net force 0? Can you find the distance where the net force is 0? Okay, let's say it's going to be somewhere here. Okay, can you find this distance? What is the distance away from A? The P going to achieve net force 0. How are you going to start the working first? F what? FA must be same as FB. Yes, this way. This is how you start your working first. FA equals to FB. Okay, the force of both same. Okay, now we want to find the X. I put as an X. Okay, FA. How do you put the FB values? FA, what are the charge you put? I put a K for my convenience. Q is what? Q of A and P, you're going to write, right? 2 times 10 power negative 3. Then the charge of P is what? Charge of P given, yeah. 1 times 10 power negative 3. Okay. How do you put the distance here? How do you put the distance here for the A?
X squared.
X squared, good. You put X squared. So B, I'm not interested in the charge. I think you should know what charge to place. How do you put the distance now for B?
6x.
Yeah. 6 plus X. This is the trap. Should be 6 plus X squared. Okay, the X squared. 6 plus X squared. Because for the B, right? For the B, 6 plus the X need to be added. Yeah, 6 plus X squared. So those who figure out this equation must be FA equals to FB, then these are the formation with the unknown should be, then you can get the answer. Then you can get that answer. Okay, those who never figure out FA must be equals to FB, I think majority should figure out FA equals to FB, but I think some of you might not figure out this is X and this is 6 plus X. Those who figure out this X and 6 plus X, okay, you are on correct track. You should be able to get the answer later. Okay, any problem with this suggestion? Okay, so those who get the third region to achieve net force 0, you are good, correct? Very good visualization. And those feel this should be X, this should be 6 plus X, that means you completed. You understand how to do the question already. Okay, so I don't want you to do the working because it's a very long-winded. First, main thing I want to do is get the idea how to place the values. Forces in electric field don't include the sign of the charge, and you should know which region the force net force becomes 0. Okay, then it is the long-winded working as I show you. It's long-winded working for that. FA is X squared, FB is, you see, X plus 6 squared, and this is X squared, and we equate the force, we might end up getting a quadratic. So this is the answer you'll get. Okay, so don't want to waste of time. I want you to do, but understand the concept. FA equals FP and X squared and X plus 6. Any questions from here for this question? Okay, no. Okay, good. So any question, you just can tell me anytime. Okay, let's move forward. Okay, so that's about electric force. Okay, Coulombs law, electric force. Okay, before I go to electric field again, okay, can you tell me what is the difference between electric force and gravitational force? Anyone? What is the difference between electric force and gravitational force? What is the differences? What is the similarity? In exam, they'll ask, what is the differences between electric force and gravitational force? And what is the similarity between 2-point masses and 2-point charges? Anyone? What is the difference?
The object they act their forces on is different.
Again, sorry. In electric force, the forces can be attractive and repulsive. Okay. In electric force, in the electric field, the force can be attractive or repulsive because it depends on the nature of the charge. Gravitational force is only attractive in nature. Okay, that's one main differences. What is the similarity? between electric force and gravitational force? Anyone? Anyone can give a similarity? What is the similarity between electric force and gravitational force? Anyone? The force is inversely proportional to the, both force are inversely proportional to the square of the distance. That's the similarity. Okay. Your gravitational force is F equals to Gmm over R squared, and your electric force now is K Q1 Q2 over R squared. Both force are inversely proportional to the square of the distance. That's the differences. Okay. Okay, so that's about force. Okay, let's move on. Next is electric field. Okay, AS, you learned what is electric field, what is electric field strength. So what is electric field? The definition is on top. Electric field is a region where a force acts on a charged body. A charged body placed in the region. Okay, so these are the patterns of electric field. Okay, so far in past years, the type of electric field they ask you to draw is only the point charge. Only the point charge. The point charge. They ask to draw for the positive charge. Positive charge, of course, is going outward. Radially going outward, and of course, negative charge is going inward. These are the two type of pattern they ask you to draw. Okay, and yeah, the one year they asked there is one surface as a positive one column. They show the field pattern. Then they say there is another sphere which has 5 columns. Draw the pattern. On this they asked. So of course, you know what, the number of field lines must be increased. Like that field density must be greater compared to the one column, right? This is what has been asked. So far, they never even asked the pattern for positive and negative. Draw the pattern. You know this pattern like this, right? So far in A2, they never asked this pattern. Normally, they go for point charges. Okay. So the one shown here is a quite complex one, 3D. I don't think so they will ask this. The most I think maybe positive and negative. This pattern you have to know. Okay, so electric field line is a region where a force charge particle experience force. The field line always move from positive to negative. Okay. So yeah, this is more field lines. These field lines we learned in your AS parallel plate, producing a uniform field. Our focus A2 is non-uniform field. Non-uniform field. So yeah, an electric field can be represented by line of forces. You learned this. The line of forces electric field shows the path of electron, a path along which a charged particle would move in the field. Can you tell me? I told you this in AS. What is the significance of this arrow? What is the significance of this arrow? Why the arrow is pointing outward? What is the significance of this arrow? Is the direction where a positive charge or negative charge would experience a force. Is a direction of where a positive test charge would experience force. That is the significance of this arrow. Okay. Okay, this is another complex one. Okay, so remember, recall back about the field line. They asked draw an exam. The field line, let's say if this surface, the field line when comes out must be 90 degrees from the surface. Okay, and the field line cannot cross. If it cross, it's wrong. Cannot cross like this. The field line have to come out 90 degrees from the surface. The field line will make a turning without crossing. Okay, let's say this is the positive, and you have a plate negative here. When the field line reach the negative plate, when reach also it should be 90 degrees. Okay, the field line must be 90 degrees. The field line separation tells the strength of the field. You learn that in your AS work. Okay. Okay, so recall back electric field strength. Your AS, we have to recall back here too. What is electric field strength? Of course, known as electric field strength intensity. Electric field strength definition is the force acting on a unit positive test charge placed at that point. The same definition as your AS. Okay, what is the formula linked to electric field strength? Yes. Okay, this is the new formula. Okay, you know The old formula you learned electric field strength is what? E equals to force per unit test charge. Positive test charge. This, remember, it's a test charge. Okay, it's a test charge. Okay, now we're going to find how the electrical strength will be for a point charge. Let's say you have a positive, the field is going outward, it's going in outward. I want to find the electric field strength at this point. Okay, so of course still is force acting on per unit positive test charge. If you have a small test charge here, and this test charge experiences a force of F, so the field at this point is force per unit test charge. Remember, this field is caused by the positive test charge or the center charge. The F over small q is the field of which charge? The capital charge, the center charge, the center charge. Okay, the capital charge cannot feel its own field. Okay, I think I told you this last time. Do an object, is it affected by its own electric field? Is it Earth? For example, we take Earth. Earth, is it affected by its own gravitational field? Is it Earth affected by its own gravitational field? That means, is it Earth experiencing force due to its own field? No, right? Gravitational field is not affected by its own field. It only affects other body. So only the other body can tell the strength of the Earth. Okay, the same thing. So the capital charge, it never experiences force due to its own field. Only the test charge, the small q, will experience a force due to the capital Q. So the strength of the capital Q, electric field strength of the capital Q, is equals to force divided by the test charge. Another charge experiencing force will tell the strength. Okay. Okay. Same thing in past year they asked, what is the field caused by small q? What is the field? What is the field caused by small q on capital Q? On capital Q. So how do you write the formula? The electric field caused by small q on capital Q. So is force per unit positive test charge. Now what is the test charge for the small q? Is the capital Q. F over capital Q will tell the strength of the small q, electric field strength. Okay, any problem here? Okay, so E equals to F over Q. But now we're going to find a new formula for E. You see, F for 2-point charges, the F we know is QQ over 4 pi epsilon naught r squared. Okay, so the electric field strength will be substitute this force into this formula. Okay, KQQ over QQ over 4 pi epsilon naught r squared. Then you get a new electric field strength formula. This is electric field strength formula for a point charge. This formula only can use for a point charge. A point charge which in form of sphere, a point charge. Okay, so this formula only works for point charge. This formula does not work for parallel plate. Okay, E equals to Q over 4 pi epsilon naught r squared never works for parallel plate. Never works for any other shape of let's say you have a point charge in a body like this. This electric field force is these two formulas is not works for these two. It must be a point charge, a dot charge. Okay, in form of sphere maybe. It should be E equals to KQ Q over 4 pi epsilon naught r squared. Okay, and be careful which Q survives here. Which Q survives here? The center charge. Center charge survives here. So you see, this force divided by the test charge, this force divided by the test charge to get the E, the test charge will be cancelled. The test charge will be cancelled. So the one remaining is the center charge. Okay. So conclusion is you have a body which has a charge of positive 5 coulomb. I'm asking 5 centimeter away at this point, what is the electric field strength produced by this charge? So you can straight away use this formula now. Q 4 pi epsilon naught r squared, but the Q you substitute with positive 5 coulomb. Just put 5 coulomb. No need to include the sign again. No need to include the sign. Just put 5 coulomb, and the R you can get the electric field strength. Okay, so two way you can find electric field strength. The old method you do what? 5 Coulomb 5 centimeter away. What is the electric field strength at this point? Last time you used F over Q. The F is, you must have a test charge here. Maybe the test charge you put, let's say 1 Coulomb, and let's say this test charge experiences a force of 5 Newton. Okay, so the electric field strength for 5 Coulomb is F over Q, 5 Newton force experienced by the test charge divided by the test charge. That's one way of finding the electric field strength. Okay, now another way is Q over 4 pi epsilon naught r squared. This Q must be the Q of the center charge. Don't get confused with which charge to be placed. Okay, E equals to Q over 4 pi epsilon r squared. This Q must be the center charge. Okay, if you use F over Q to find the electric field strength of the capital Q, this should be the test charge. Okay, this is the biggest mistake the student will do. Get confused with which charge to be placed. If you use F over Q to find the electric field strength of capital Q, the Q down here is the test charge. Okay, if you use E equals to the new formula, Q over 4 pi epsilon r squared, this Q must be the test charge. Okay, any questions from here? Okay, I hope you cope up. Okay, so this is the new two formulas in the list. F equals to KQQ over R squared. I think I prefer I use KQ, easier for me. But in exam, you write 1 over 4 pi epsilon naught. So KQQ over R squared is the Coulombs law. And from the Coulombs law, we get the electric field strength force. KQ over R squared. Okay, KQ R squared. Okay. Okay, so one example of the electric field strength. So find the electric field strength 50 centimeter from a positive charge 1 times 10 power negative 4 Coulomb. Okay, so they find there is a point charge. There is a point charge. It carries a 1 times 10 power negative 4 about 50 centimeter away. They are asking what is the electric field strength caused by this charge. Of course, this charge, the field is going outward. What is the strength of the field here? Okay, so the formula is KQ over R squared. This is the center charge, the center charge, charge possessed by the body. Okay, so KQ. So that's the working shown here. So Q over 4 pi epsilon R squared. Q is the charge of the center charge. So here you don't need to know the test charge anymore if you use this formula. Center charge will do to find the electric field strength its own. Okay, so you get this is the Coulomb. So when you do this calculation again, the sign of charge no need to include. Okay, don't include the sign of charge for electric field strength also. Okay. Okay, now your turn. Okay, 1 minute for you. Read the question. Try to imagine how you're going to go about. We're going to discuss the method. I don't want the full working. I just want the method. How are you going to go about? 1 minute for you. Okay, so you have an idea. So there are two charges, positive 5 Coulomb, microcoulomb, and negative 3.6 microcoulomb here. Find the magnitude and direction of E at point B. They're asking at this point B, what is the electric field strength? The net electric field strength experienced by at point B caused by these two. Okay. Of course, you have to recall back. Electric field is a vector quantity or scalar quantity. Electric field strength. Electric field strength. Is it vector quantity or scalar quantity? It's a vector quantity. It's a vector quantity as direction. So if it's a vector quantity, then it's going to be difficult because you need to consider the direction. So negative at point B, you have a positive here, you have a negative here. Okay, put a negative here. You want to find the field at B here, at this point. Okay. Positive, the field going to be outward. Therefore, the field here straight going to be at this direction. The field caused by who? Positive 5. Okay. The field caused by negative is going to inward. Negative, the field is going inward. So if you drag here, if you drag this line here, the field going to be inward to the negative. That means going acting upwards. Okay. So the field caused by negative 3.6 is actually acting upwards, vertically up at point B, upwards, because going towards the negative charge one. The positive field of positive 5 microcoulomb acting where? Is acting diagonally to the, I can say this like a southeast direction. This field here as shown in this diagram. E2 is the field caused by the positive 5 coulomb going outward from the positive. E1 is the field moving to the negative. So two fields are overlapping here, E1 and E2. So you want to find the net field. How do you find the net field? E1 is here, E2 here, like a two vector quantity. E1 is up vertically up, E2 diagonally here. So where's your net field? Sorry, net field should be this way, right? This is your net field. So the question we are looking for this net field. How to find this net field? Okay. So how do you find the net field? So it's a vector quantity. First, how do you find E1? How do you find E1 first? E1, what formula do you use? I put K, easier for me. So K, Q over R squared to be used. Okay, K, you know, Q, which Q used? E1. E1 is the field of negative 3.6. So, of course, Q you must use 3.6 times 10 power of negative 6 because micro. And divide by R use what? 6 centimeter. So 6 times 10 power of negative 2 change to meter square. So you get the E1. E1 magnitude you get upwards. So you can get the E2 also the same way. E2 you choose the positive 5. Okay, after you get these two vector, then how are you going to find it? How do you find the net? So your whole idea, how do you deal with net, what do you call vector quantities? You break them into their components. I think E1 is perfect, is perfectly vertical up. Why? E2 is diagonal. We break them into their components. We find the components EY and EX and the EY. Okay. Then the vertical one we just subtract. We find the one vertical component for EY. Then EX, only one EX there. So the EX is kept here. Then by using Pythagoras, I think Pythagoras theorem, you can get the net force. You can get the net force. Okay. So vertically, the potential, the electric field must be subtracted. E1 need to be subtracted with the vertical component of E2, which acting downwards. Okay. So yeah. So this is how the method you should go about lah. So first thing, I just erase this. So my expectation is when you read this question, you must imagine that E1 is acting vertically up, E2 acting diagonally here. Okay. Then you should recall back this formula, KQ over R squared to get the values. And you should know that don't put the sign of the charge here. Then next, what must be in your mind? My expectation is E1 is up and the E2, which is diagonal, have to break into their components. Okay, E2Y component, E2X component. Then the E2Y and the E1 need to be subtracted so that you get a single EY value, and EX is already there, so we get the net force. Okay, any you don't understand in this explanation? Okay, I hope everyone cope up. Okay, so the working is next slide. So yeah, this is the working I'm explaining just now. Okay, So you see this diagram where we find the E1 and E2. E1 we put the charge without the sign. Okay, so we got 9 and 2. Then you see the E1. E1 is horizontally X only lah. Sorry, E1 which is acting vertically up, straight up. The X component is 0. Don't have. The Y component is exactly the same value lah. The E1 which is acting vertically up for the negative charge. For a positive, the second one, we do cos 37, sine 37 to get the X component and the Y component. Y component, we write it as negative because it's directing down. We're going to subtract. So we get the total EX. EX is just the vertical one. The EY, we add both, but finally minus lah because the 2Y is negative. So we got these two. Then we use the Pythagoras theorem to get the result. And the angle also we can find. Angle is angle from horizontal. If this is the net force, what is the angle from horizontal? We can find by using the triangle EX and the EY. Okay. Any questions? Okay. Okay, class. So we go back. So yeah, my target is only about electric field strength today. So what you learned today? Electric force and electric field strength. Okay. So electric force and electric field strength both are vector quantities. Okay. When you use the charge, don't use the sign of charge into it. Okay. Okay. So just go back to one question. Okay, I go to the this Word file, okay, which you already have in the Moodle. Okay, at the back there are some questions. So yeah, Coulombs law. So K Q1 Q2 R squared 1/4 pi epsilon naught Q1 Q2. I prefer to write like this. Okay. Okay, I prefer you to write this equation. Remember, in the exam in the exam, don't write this. You need to write this. When I explaining, I'm going to write this because it's easier for me. Okay. We discuss this. Okay, we discuss this. You can redo back. Okay, now the question I'm going to focus here. We will do potential later, but first, okay. Well, the first question. Okay, come on, class. 2 minutes for you. Okay, take a piece of paper. This is on the Moodle, but no working. You have to get the working now. Okay, please get me the working for the number 1. 2 minutes for you. Try to get this answer. Okay, the answer is at the side. Get me the answer. So F equals to 1/4 pi epsilon naught Q1 Q2 over bracket R squared. Electric field strength is 1/4 pi epsilon naught Q over R squared. Okay, here instead of Q1 Q2, I'll put like this: capital Q, small q. Capital Q the center charge, small q like the test charge now. Okay. Electric field, the center charge is survived. Okay. So come on, 2 minutes. Get me the answer for the A. I believe you remember the constants. Let me write the constant here. The K, I straight away put K. And K is what? 9 times 10 power of 9. The K value, right? Okay, let me. Sorry, guys. Let me check the constant back. Hold on. Just for a while. Yeah, take down the K. K is 9 times 10 power 9. When you write the formula, you write this formula. Okay, then straight away, the 1 over 4 pi epsilon naught, you can put this formula straight away. The value 9 times 10 power 9. Go back to the question. Okay. Okay, so take a piece of paper, try to do the question. Get the answer inside the bracket. If you get, then okay. So 2-point charges, 2-point charges, same magnitude, are separated by a distance of 2 opposite charges. Okay. Okay, one is positive, the one is negative. Separated for a distance of 15 centimeter. Okay, and both are 2 times 10 power of negative 7 coulomb. Okay, so what is the force? Find the magnitude and the direction of the electric field strength, or the electric field strength. What is the electric field strength? At the midpoint between the charges, or the electric field strength at the center here. What is the E at the center? So E of 1, E of 2. Two fields are overlapping at the center, right? The positive field is going outward. At the center, it's moving to the right. Okay. So field of 1 is moving to the right. E1 is moving to the right at that point. E negative, the 2, E negative also moving to the right one. Both fields are moving to the right. So the E positive is to the right. The E caused by the negative charge also to the right. Both are to the right. Okay. So what is the electric field strength at the center? So you need to find E positive and you need to find E negative. Then what do you do? The both field, you add or subtract. You add them, right? Both E plus and E negative, you need to add them. Why? Because both are pointing towards the same direction. Okay, but how do you find E positive? What formula to use? KQ over R squared. Okay, which Q you use? Which R you use? That's important. Which Q do you use? Q of positive, the center charge, which is how much? 2 times 10 power negative 7. Which R do you use? What R do you use? Because it's 15 centimeters separated. Find the magnitude of the direction of the electric field at the midpoint. So R do you use how much? Anyone? Use the center point one. So 15 centimeter divided by 2. So 15 divided by 2. It's your R. But because it's in centimeter, you have to convert to meter. Okay, so 7.5 centimeter, please convert to meter. Then you get E plus. And E minus also, I think, going to get the same magnitude. So the E plus, whatever answer you get for E plus times 2, I think that should be the answer. You should get 6.39 times 10 to the power of 5. Okay, so anyone got problem with this? Okay, so you must imagine that because they want the field at the center, one is positive, one negative, both field at the center going to be the same direction to the right. Therefore, both field need to be added. The Q must use the Q their own charge, and the R is 7.5. And which direction is the final direction of the electric field strength? So this is the answer, right? Towards the negative charge, right? You see, the both field are directing towards the negative charge. So yeah, so the answer should be towards the negative charge. So that's for A. Okay. So substitute, put the numbers. K is 9 times 10 power of 9. Get an experience how to do these electric field questions. The R change to centimeter. Centimeter change to meter. Okay. So I assume everyone got the A. Okay, now go for the B. We'll try for B. Get the answer in the bracket. Find the magnitude and the direction of the force acting on an electron placed at the midpoint. So B, they're asking for the force. So B, they're asking for the force. So you do here. The force on electron. Okay. So force on electron. So what formula must come to your mind? Of course, what? K Q over R squared, right? This is the formula must come to your mind. But now because we know the electric field strength on top, so the force is Q times E, right? You know your old idea, force is Q times the electric field strength. We know the electric field strength already from part A. So we just multiply by the charge of electron. So 1.6 times 10 power of negative 19. Just multiply by the electric field strength at that point, which is how much? We calculated earlier, 6.39 times 10 power of 5 would give us answer, the Newton. I think in this case, we don't need to go for this formula. We don't need to go for this formula because electric field strength we know already. So electric field strength times the test charge, you get the force. The whole idea. Whole idea, you know what? Electric field strength times the charge is your force experienced by that particle. So you should get this answer. And the direction should be towards the positive charge. Of course, it's a negative charge electron. So electron will go move towards the positive charge. Okay. Any questions from here? Hope you get the first answer. Everyone? Can,
Yeah.
Okay. Let's move to the next question. Okay. This is in the note file at the back. You have this question. Okay. The other question I want to select is okay. So I can't select any of them. Okay, sorry. So the remaining questions are about the next part. Okay, next part. Okay. So let me go back to the past year. Past year, just some questions. The one we learned today only. Okay, majority. Okay, the first answer. So, like Juno 6, for a conducting sphere, what is meant by defined electrical strength? Force per unit, positive, test charge. Okay, state the formula for the electrical strength at the surface of the sphere. Also state the meaning of any other symbols used. So, what is the answer? State me just write it. So what's the answer? The electric field strength at the surface of the sphere. Also state the meaning of any other symbols. So of course, the formula you must write is E equals to what? Equals to Q over 4 pi epsilon naught R squared. R squared. Then you need to explain the symbols. What is Q? Q is the sphere word. The Q is the charge possessed by the sphere. R is what? R is the radius of the sphere, because they want the E at the surface of the sphere. So radius of the sphere are always calculated from the center, body to the point. And epsilon naught, we just call it as a permittivity of free space, special name, permittivity of free space. Okay. As I said, 4 pi epsilon naught is a constant used for electric field strength generated by a body which the transmitting medium is a vacuum. If it's a transmitting medium is air, then this constant going to change only for electric field strength. Never happen for gravity. Gravity, the capital G is constant. Okay, it's universe, but electric field strength, the constant can change, depend to the medium line between. Okay, so yeah, guys, after that, I think we can proceed. Okay, so I think I have to teach you with this electric potential energy. Okay, but before we go to this, let's recap what you learned in your let me check. Recall back your gravity, because the gravity is quite close linked to the electric field strength. Okay, we're going to recall back the gravitational formulas. Then we're going to clear this. Sorry, let me. It's not working. Okay, plus. So I just want to show the link between both of them. Okay, for gravity, for the case of gravity and electric. Okay, electric. So you see the similarity. So Newton's law says what? Newton's law says that F equals to Gmm over R squared. So Coulomb says what? Coulomb says that F equals to 1 over 4 pi epsilon naught Q Q over R squared. Okay. Next, gravitational field strength. Gravitational field strength. Gravitational field strength. The G is what formula? Anyone can recall? Now you know electric field strength. What? Electric field strength is what? It's similar. Electric field strength is force per unit positive test charge. Okay. Finally, end up getting what? KQ over R squared. Okay. Gravitational field strength what? Force per unit. Anyone? Force per unit? Test mass. And the formula for gravitational field strength is what? Gm over R squared. This is the old one you learned. Look at the electric field. Similar. Just constant G now is K. Mass has been replaced with Q. Other than that, same. Okay. So why I'm writing this? Because I want to tell you the third one. Okay. Please, anyone can recall me. After force, gravitational field strength, you learn. The third thing you learn about gravity is what? Gravitational potential. Gravitational potential. Because why I want you to recall this, because you can predict what's going to happen here in electric potential now. This is electric potential. Electric potential works the same way. Okay. Can anyone tell me what is gravitational potential? The symbol is V. Yeah, V. What is gravitational potential formula? Anyone? What over what is gravitational potential? Gm over R. Good, correct. Gm over R. But what is the gravitation potential defined as? Anyone? What over what? What over what is gravitational potential? Anyone? Work done? Work done per unit?
Mass.
Mass, yes, very good. Gravity. Recall back this. So let's say this is the Earth. This is the Earth. So let's say at this point, what is the potential here? So gravity potential is the work done to bring a work done per unit mass, 1 kg of mass out. Work done per unit mass to bring the object from infinity to that point. That's your gravitational potential here. Work done per unit mass to move from infinity to that point. But the formula we found is Gm over R. Okay. You can. Okay, now can you tell me what electric potential going to be? Similar. What is the formula for electric potential going to be? What is the definition for electric potential going to be? Similar. So electric potential is V. Again, V, electric potential. Okay. What over what will be the electric potential? And what do you think the final formula will be? Anyone? Electric potential is still a charge, center charge. The charge create a potential at one point. Okay. I think potential is more famous in electric compared to gravity in your early studies. Early studies, potential means we focus to electric potential. A charge produces a potential here. What is meant by potential at this point? Is the same thing. The amount of, same as gravity, the amount of work done. The amount of work done to bring a unit positive test charge from infinity to that point, to this point. That's gravitational, electric potential. Electric potential is work done per unit positive test charge. You must say positive test charge. All the definition in electric, we use positive test charge. Electric potential, force per unit positive test charge. Electric potential then, work done to bring a unit positive test charge from infinity to that point. So what is the formula do you think could be? Gm over R. So now we're going to be what? KQ over R. Yes, this is the formula. Okay. What is the unit for gravitational potential last time? What is the gravitational potential unit last time? Work done per unit mass. So work is joule, per unit mass is kg, joule per kg. What do you think electric potential unit will be? Work done per unit charge. So it will be joule per coulomb. Joule per coulomb. So that is your electric potential. Okay. So yeah, our discussion next class is going to be about this about this what electric potential. After gravitational potential, what we learn in your gravity? Gravitational potential energy. We learn gravitational potential energy. Okay, U. What is gravitational potential energy and gravitational potential linked? Anyone? The gravitational potential energy is equals to what times what?
Gravitational potential times mass.
Okay, very good. Potential times mass. The test mass times the gravitational potential is the gravitational potential energy. Unit is joule. I think we well versed this last time when we talked about gravity. So here in electric also we go for electric potential energy after this. So what do you think it's going to be? Electric potential energy is going to work the same way. The potential of electric potential times the charge, the test charge, get the electric potential. Okay. So the flow is going to be about the same. The only is gravity is only attractive in nature. Electric is can be attractive, can be repulsive. That's the one differences. Gravity is about mass, electric about charge. Okay. Yeah. So okay, I don't want to move forward. Tomorrow we'll be discussing about this about gravitational potential energy, the counterpart, electric potential energy. We'll discuss this. Okay. So yeah. So tomorrow I think you can go through the slide. You can go through the slide. Imagine like a gravity in your mind. You read through. You can understand. So tomorrow I'll be going through this. Okay, electric potential, gravitational potential. Then we finish this topic. Okay, tomorrow I think we can finish this topic. Okay. Any questions?
No.
No questions, eh? Okay, so tomorrow I hope everyone join in the. Okay, okay. Currently they are 22, 21 of you. Some of you couldn't join. Danish all can. Okay, so thanks. I'll see you back tomorrow 10:30. You do a revision about electric potential and electric potential energy. Any questions? If you don't have questions, we can stop here. Okay, no questions, Okay, so I put the video on the Moodle, as usual. Okay, thanks.
Thank you.
Thank you, Jer.